Okay, guys. Today we're going to talk about multiplying binomials, and I know that we have talked about multiplying binomials on Monday through a notes section, but we're going to try something new. Today we're going to talk about the special cases that we do run into when we are multiplying binomials. First thing I want you guys to keep in mind while going through this are the various methods that we use. Okay, we have the FOIL method that we use. We also have the area method that we use, and last but not least, the double distributive method. Okay, and just keep in mind that that FOIL method does stand for first outside, inside, and last. What I do want to mention about the FOIL method is that FOIL method actually only works when we are dealing with a binomial times a binomial. We don't reference FOIL for anything else because the FOIL method only works when we're multiplying two binomials together, and we'll see that. The area method is used moving forward as well as the double distributive method. So what I'm going to go through and do for you are a couple of examples today. What I'm going to do is I'm going to use the FOIL method, I'm going to use the area method, and then I will absolutely do one problem where we start talking about the double distributive method. So what we want to take into consideration here is the fact that when we are multiplying binomials with the special cases, if we take a look at example 1, we have x minus 8, and then we have x plus 8. Okay, so if we're going to use the FOIL method, okay, the FOIL method says first outside, inside, last. We take a look at our first term here, and our first terms are x times x, and when we multiply those together, we're going to get x squared. Okay, then we're going to take a look at our outside terms. Our outside terms here are x and positive 8, and when we multiply those together, we're going to get a positive 8x. And then we will reference our, well, let me go ahead and write O stands for outside. And then we have the I, which stands for inside. And that's when we take our two inside terms. In this case, we are going to be multiplying this negative 8 and this x. And when we multiply those together, we get negative 8x. And then we take a look at this L, and the L stands for last, okay? So last here, it's going to be our negative 8 times our positive 8, and when we multiply those together, we get negative 64. Now, what I want you guys to take a look at with this special case, and these are the difference of perfect squares, is that when we go ahead and multiply these together using whatever method you choose, I want you to notice what happens with the middle terms here, that we have a positive 8x and we have a negative 8x. So what actually happens is when we combine those, that's equal to 0. So what we're able to take out of this is the x squared drops in, then negative 64 drops in, and our final solution is x squared minus 64. If that first example didn't help clarify anything for you, I'm going to go through another example of a difference of perfect squares. Maybe you don't, maybe you're a student who doesn't like the FOIL method, which is okay. Whatever method that you feel most comfortable with is the method that I ultimately like you to use. But what I'll do is I'll go through another method. Example 2 here from the notes is 2x plus 3 and 2x minus 3. Okay, and we'll use the area method here. Okay, so here we have 2x plus 3. And here we have 2x minus 3. So when we're using the area method, it actually works similar to a multiplication table. So what we're going to do is we're going to take a look at this 2x right here. Okay, and this 2x right here. And when I multiply those together, I'm actually going to get 4x squared. And then I'm going to take a look at this 2x again, along with this 3. And when I multiply those together, I'm going to get a positive 6x. I have a negative 3 here and a 2x here, and I multiply those together, I get negative 6x. And I have a negative 3 here and a 3 here, and they meet down here. Multiplied together, I get negative 9. Okay, with the area method, what you should begin to notice here is we've got this negative 6x working down here. Okay, and we've got this positive 6x working over here. When I go ahead to combine those two, what I should notice is that that 6x with this negative 6x, when they combine, we're going to get 0. And then I'm able to pull out as my final solution 4x squared minus 9. And that is my final solution. And if that is not the method of your choice and you would like to go through and use another method, the last method that we did talk about is the double distributive method. Okay, so we're going to take a look at that method now, and this is going to be another example off record, not on the notes. This would be example 3. Let's just say we took x minus 3 times x plus 3. And the double distributive method has you take that x first, okay, and distribute that to the x plus 3. And then it has you take this minus 3 out here and also distribute that to the x plus 3. So using the double distributive method here, x times x is x squared, and then x times 3 is positive 3x. Okay, and that sort of took care of the left-hand side there. And then we'll move into this negative 3 here, and if I distribute that to the x and the 3, what I'm going to get is minus 3x. And then negative 3 times 3 is negative 9. So then I can take a look here, taking a look at my middle terms here. I'll go ahead and highlight them for you. What I should notice is that if I combine 3x and negative 3x here, that's going to be 0. So what I'm able to take out of this is I get x squared minus 9 as my final solution. Okay. Moving forward, I am going to use the FOIL method or the area method. If you like the double distributive method, you can absolutely use that method. You should notice that all 3 methods actually get you the same answer. So those were the cases of the difference of perfect squares. And what I wanted you to take a look at here was that negative 3 and positive 3 are opposites. If we go ahead and take a look at the notes here, we have negative 8, positive 8. Those are opposites. Positive 3, negative 3. Those are opposites. Okay, so when that is actually happening, our middle terms are canceling out, and we're left with our final solution over here as such. What we're going to look at is the square of binomials. And what we're going to have to do is we're going to have to call on a little bit of prereq knowledge or things that we knew before coming in today, into today's lesson. So what I'd like to start off with, just to jog your memory, is if I had 9 in parentheses squared, what I want you to realize is that another way to go ahead and write this would have been 9 times 9, which is 81. This is a very trivial problem. But now, this sort of prereq knowledge is going to help us tackle these special cases in terms of squaring binomials. So now we're looking at something like, let's just say example 1 here. We have x plus 7, and that is the quantity squared. Well, if we don't know how to really deal with this, the first thing we're going to want to do is we're going to want to rewrite this, and that we're going to be able to rewrite this as x plus 7 times x plus 7. Okay. And then we can go ahead and work our way through this. I'm just going to FOIL this. I'm going to rewrite it down here. X plus 7, x plus 7. Okay. And then when I go ahead and multiply here, x times x is going to give me x squared. Those are my first terms. My outside is x times 7. Sorry about that. It's going to be a 7x. Then we're going to have my inside terms here. 7 times x. Again, another 7x. And then our last terms here, 7 times 7. Just going to give me 49. Okay. What we'll notice in the middle here again, okay, our middle terms happen to be our like terms, so we are able to combine these, okay, by addition here. I'm going to drop in my x squared. Okay, 7x plus 7x is positive 14x plus 49. And that would be our final solution. Now, What we want to notice moving forward here is the square of a binomial, they actually use a shortcut. Now, if you can't remember this shortcut, that's okay. We can still go through this problem like we know how to do using the FOIL method or the area method or the double distributive. That's fine. But if you could happen to, what I'm going to do is I'm going to leave the answer. I'm going to erase all the work in the middle, and I'm going to show you guys they use a little bit of a shortcut to get to the answer. The shortcut that they use for these special cases when you have a binomial squared is they use the square double square method. Okay, so if you're ever looking for a shortcut, and perhaps you may need a shortcut in the future when math problems get a little bit longer, we have the square double square method. Okay, and I'll show you how this works. The square double square method tells you to take your first term. Sorry, I have the eraser out. I should not have the eraser. Take your first term, okay, which is our x term. Underline that in black. And it says take your first term and square it. So our first term squared is going to give me x squared. Okay. And then what it has us do for this double part is to take whatever we have inside of the binomial. Okay. And we're going to multiply those together. So 7 times x, and we're going to get a 7x. Okay. And then it says just double that. Okay. So if we double 7x, we're going to end up with our 14x. And then lastly, it has us taking our last term here, this 7, and it says square 7. So if I square 7, I'm going to end up with 49 as my final solution. Okay. So that would be square double square. Again, square that first term, take everything inside, multiply it together, double it, and square your last term. And I will show you guys one more example. What I'll do is I will use the shortcut first, and then I will confirm it by the use of the area method. So example 2 has us looking at 3x minus 2, all this quantity squared. So if I'm using the shortcut, it says square that first term. So if I take my 3x and I square it, I'm going to get 9x squared. Okay. Then I'm going to take a look at 3x and negative 2 here. When I multiply those together, I get negative 6x. But it says to double that, so that's going to give me negative 12x. And then it says take a look at your last term here, this being the negative 2. And if I square negative 2, I'm going to end up with positive 4. And just to show you real quick, in the area method, what we have is 3x. Sorry about that, ran into some technical difficulties. I think we're back up and running now. We're going to take that 3x minus 2 and then 3x minus 2 because we have 3x minus 2 squared. And if we multiply 3x by 3x, we're going to get 9x squared here. 3x times negative 2 is going to give me negative 6x. Our negative 2 times our negative 3x is going to give us, I'm sorry, that's not, it's a positive 3x is going to give us negative 6x, and negative 2 times negative 2 is going to give us positive 4. What we're going to notice here again is that this negative 6x and negative 6x are like terms. So when I go ahead and combine everything, I'm going to get 9x squared minus 12x plus 4. Again, what you'll notice is that these two are the exact same solution. So again, you can feel free to use your shortcut, or you can use your area method or the FOIL method. But these were the special cases of binomials that you will run into. The first being the difference of perfect squares, where our middle terms actually end up canceling out. And the square of a binomial, where we have our square double square method that we can use. Again, these are just methods that we can use as shortcuts. We don't always need to rely on them. You will always get the same answer whether or not you use the shortcut or the one of the three methods, being the FOIL method, the area method, or the double distributive method. I hope that this video helped you guys out. I plan on doing these a lot more frequently for you guys in terms of new lessons. So yeah, hopefully it helps out with the homework, and enjoy the rest of your day, guys.